produces a 20 by 20, so that's 20 centimeters by 20 centimeters plate and frame filter, which uses a depth filtration medium, cellulose-based, and has some diatomaceous earth. The flow rate through a 20 by 20 plate and frame is about 15 gallons per sheet per hour. When we go up in scale to a larger facility, one would use a 40 by 40 plate and frame system. With this, we have the ability to do 4 times the volume, as it is now 4 of the 20 by 20 centimeter sheets, and can do 45 to 60 gallons per hour per sheet, depending upon the level of filtration that you're doing. With each of these different sheets, you can do a coarse filtration, we can do a medium filtration, and we can get down to polishing in preparation for running a line for sterile filtration, in which we would move to a cartridge system. In the cartridge system, you generally will have a nominal and an absolute filter. The nominal filter is catching and collecting 99% of the pore size in which it's regulated at, whether it's a 0.65 micron, 0.45 micron, and then you have the absolute filter, which is guaranteeing that it's collecting everything, which assures your sterility. So those are the 3 different types of filtration mediums that we've got, and we'll talk a little bit more specifically about each one. A common filtration system for small wineries or either small lot production is a 20 by 20 plate and frame filter. And we're just going to walk through the flow of the wine in this system. The wine will enter through the hose here. This actually has a pump attached to it. Some of them won't, and so you can still feed through this side of the system. There's a pressure gauge here, which we're going to run between 1 and 2 bar. 1 bar is approximately 14.5 psi. As the wine enters the system, it's going to fill this column. Inside the column, you will see that there are 2 holes. Those holes will then allow the wine to flow, because wine as a liquid is going to move through the path of least resistance. It will flow onto the plate, and then the wine will move through the paths. When we talk about our filtration medium, the paths, the wine is going to flow through the rough side and exit out the smooth. So if the wine is flowing through the plate, it's going to enter in the rough side of the path and exit through the smooth. As it does that, it's going to then shift to the outer edge of this plate and frame system into this outer column, and then the wine will exit. The thing to keep in mind is this is happening simultaneously on each pad. So the wine is not moving back and forth and going through each and every pad. It's only going to move through or migrate through one pad. And then once it hits the column, it's going to exit through the system. On each end, we have what's called an end plate, which starts the configuration. As the wine flows into the column, it's going to proceed through the inlets that are inside this chamber, and it's going to move and fill this entire plate, both on this side and on this side of the plate. As the wine enters there, it's continuing to have pressure, and it's going to then move through the rough side of the filter medium. All the wine needs to go from rough and exit through the smooth. As it hits the pad on the other side, it is then going to be shifted to the outside column in the 20 by 20. The wine is going to enter into this chamber. The holes are inside each one of these. The wine will move through onto this pad and cross through the rough to the smooth to the other plates and migrate to the other column and exit. And that is happening simultaneously in each of the paths. The 40 by 40 plate and frame system allows us to do a double filtration, in which we're able to do a filtration at a coarse and then a polish, or a polish and then a sterile, and so we're able to do 2 filtrations in one pass. The way this system is set up is this initial chamber on this side of our diversion plate will do the initial filtration. The wine will then move to the second section and get filtered at a finer level. So typically you'll do a 1.5 micron, which would be a polish, and then a 0.45 micron, which would be a sterile. And the wine would then be ready to go to cartridge filtration. The wine will enter through this bottom valve. We always feed from the bottom up, bleeding out air as it enters into the system. As the wine enters, we have our end plate here. It's going to fill this initial chamber. It's going to penetrate through, again running through the course and exiting out smooth. The wine will end up in this chamber over here, and we will have this valve closed. So now the only place that it has to go is to move through over to this chamber. We'll have our finer filtration medium. We'll end up over in this chamber and we'll exit. The big thing that we're looking for in this kind of filtration, when we're doing a double, is the difference between our entry point and our exit point with regards to pressure. As the difference continues to rise, it's an indication that the filters are being plugged. We're going to flow again between 1 and 2 bars, which is each bar is 14.5 psi. As the wine enters this column, it is impacted by the diversion plate. You can see that there is no place for it to exit on this side, but there is an opening on this side. That forces the wine to go through the filtration medium into this chamber and allows it to pass through this chamber onto the next set in which we're doing our sterile filter. As the wine is moving in, initially you're going to see 2 back plates, one against the front of the plate, one against our diversion plate. The back plate stops the wine from exiting, and then you'll see the alternating system of our plates. The inlets allow for the wine to enter, and it will come through each side. Notice on the other side, there's no place for the wine to go. The gasketed side. So as the wine is flowing into this chamber, it will go through the inlet and will then exit both directions. We want our wine to flow through the coarse side of the pad. So we would place the coarse end facing this plate, and then we would sandwich that plate, again with the coarse facing. So now both courses are facing each other or sandwiching, because the wine will be entering, filling the plate, exiting through, hitting these other plates and flowing to the other chamber, where then it will move to the other side and go through a similar process. There's a gasket here, so wine cannot flow out this plate. That means the smooth will sandwich the gaskets. And that's the alternation that you go back and forth when setting up for a double filtration. Now the wine is moved through our plate frame filter, and we're preparing a white wine for sterile filtration as they've gone through sterile pads, which are 0.45 microns, though it's not guaranteed sterility. Those pads allow product larger and smaller to go through, because we need to go through a system that guarantees sterility. That's where the cartridge filtration occurs. The flow of wine will enter initially through here into this cartridge system, which is a nominal filter, which guarantees 99% of the product of that size will be caught or captured. We'll then move over to the next chamber, which has our absolute filter. This filter is the one that is guaranteeing to remove everything of the stated size, whether it's 0.65 microns, 0.45 microns, or otherwise. Then the wine will exit and move to the bottling system. As we look inside of these canisters, you will see the filtration medium. This again is a nominal filtration. It will capture the majority of the product to really guarantee that the last filter, which is your absolute filter, is doing the least amount of work as possible. As the wine enters into the system, it's going to flow in and through this into the canister, and it gets forced through the medium, down through the hole, and then exits. This is the filter that we would do a bubble test, because we want to ensure that the integrity of the filter is protected and that we are assured it is filtering at the level stated. So for instance, at sterility 0.45 microns, we want to make sure that this filter is truly capturing and is in the system correctly, so that we are certain anything that passes through is of sterile quality. The method that we use to do that is called the bubble test. By placing this system together, we can force air, inert gas, typically nitrogen, into this canister and test down through the bottom here, be in water. We force in the inert gas up to a pressure of between 20 and 30 psi. That is dictated by the manufacturer. They'll state on the sheets that you receive when you put in the filters what the bubble point is. Most are in the 22 to 26 range. As you raise the pressure, you're checking to make sure no bubbles are coming through, steady bubbles, streams of bubbles. If they are, then either the filter is compromised or it's not been put in the system correctly and you need to check the gaskets. As you get to that bubble point, let's assume it's 26 psi, and if you're able to take it up to 27 and we don't see any bubbling, we're certain the integrity of the filter is satisfactory.